Hey there 216ers, welcome back to another one of our semi-weekly discussion videos. Today for Monday, April 8th, we're going to be talking about Lab 10, which is makefiles, what they are, and how you can make them for yourselves. Let's jump right in. Alrighty, so let's jump right in. What are makefiles? Well, so far in this class, we've just been typing make in order to compile all of our programs. And the makefiles that Kaufman's created have also been able to create zips of our projects for us and test our projects and clean up our projects for us. So make is really just a program that does all of your compilation for you. Let's look at what we have here. So we have 3 C files. We have our main file, then our func01 file, and our func02 file. And then we have a funcs.h header, which defines some of our functions for us. And we can see it here. Here's our main file, and it just prints that it's calling function 1, and then it calls function 1, which we can see on the right side here, just prints hello. Then we go back to our main file, we print calling function 2, and then we call function 2, which it also says hello. It says hello back. Maybe we can change that to say, I don't know, hi back. Great. Okay. And then our header file, which is included in all of these. Actually, maybe we don't need to include it here. Anyways, our header file, it just defines our functions so that our main function knows where to look. Okay, so if we tried to compile these, we could do this by hand. We could type gcc and, well, I already have an a.out, so rm a.out. We can type gcc and compile all of these together. We can have main.c and func01.c and func02.c. And it did nothing, so it probably worked, but let's check. Yep, we have an a.out now, and if we run a.out, there we go. We see main prints that it's calling function 1. Function 1 says hello, and then main calls function 2, and function 2 says hi back. Perfect. But we can already see that this GCC and all of our C files can get a little bit beefy if we had so many C files. Let me add in that we can also, well, hold on, let me just remove a.out, and that's about it. So before I was just creating an a.out, but now we can do gcc tac-c, which compiles just one file, and we can compile each of these files on their own. So after compiling main.c, we see that we get this main.o, an object file, which is almost a binary, almost a machine code file or computer readable file, except not quite, because main.o still requires, or main.c, as we can see here, it still requires this funds.h, and it calls these functions which are defined elsewhere. And so if we tried to run main.o, well, permission denied, it's not runnable. But we can do gcc tac-c, and that would be the same as doing gcc main.c. Well, we see that we have a linker failure. These functions aren't defined anywhere. Okay, so gcc tac-c, we can do func01.c, and then we can do the same for func02. And we see we have this main.o, we have this func01.o and func02.o. And now we can link them, we can invoke the linker and say, Well, main.o and func01.o and func02.o, we're going to link them all together. It did nothing, but now we have this a.out file here, and we can run a.out, and it does the same thing. So now we can see that we can compile each file on its own, and then invoke the linker to bring them all together. But we're still doing this by hand, so if we had a super huge project, we would have to do each of those steps one by one, and then link them all by hand every single time we wanted to compile. There must be a better way, right? Well, there is. And that's makefiles. So let's go into our makefile. Great, there's nothing here, but that's for us to write. So I'm going to start off, or we're going to start off with something you won't understand for now. We're going to say all. All is a rule, and all colon, and we depend on, well, let's call our project or our program funcs. And so what this is saying is we have this rule all, and in makefiles, this all rule is, if you just type make, like you can do in your projects and your labs that Kaufman's built for you, you can just type make and it will run this all first, and it depends on a file called funcs. Well, we see that we don't have a file called funcs here, and so if we type make, maybe I didn't save. If we type make, yeah, no rule to make target funcs needed by all. So let's, apologies, let's write this funcs rule. Okay, so we just write it exactly the same how we did all, and funcs we want it to rely on a few things. We want it to rely on func01.o and func02.o. Remember when we did this step by step, we went, okay, well, func01, we compile that into a .o, and func02 we compile into a .o, and actually we also need main.o. So we compiled each of those, and now we link them together using GCC and main.o, func01.o, func02.o, and we can use this tac-o at the beginning here to say funcs is the name of our program, so output to a file called funcs. Great, and so these are the three basic steps of a rule in a makefile. We have the rule name here, the dependencies, so what the rule requires, what files the rule requires to exist before it runs, and then the command or commands, if we have another command, that are run once the rule is called and the dependencies are met. And by the way, this here is a tab. It won't work if you input spaces. If we see here, well, GCC, it's no longer purple, which means bad things in my syntax highlighting. Okay, so we've defined this rule that will eventually create our program, but we still haven't compiled any of these files. So let's make a rule for each of those. So main.o is our rule, and what do we depend on? Well, we depend on main.c, and if we remember back, we need to include our funds.h file. So we'll have those be our dependencies. Insert a tab, and we can just gcc taxc main.c. So that will create a main.o. And we can do this for func01.o, and it requires func01.c and funds.h. And we can gcc func01.c. And finally, we can have func02.o, and we require func02.c and funds.h. And then we use gcc to func02.c. All right. So now, if we now we've written the main body, or basically we've written the functionality to do exactly what we did before, which is compile each file separately and then link them together. So when we see these dependencies, when our funcs sees these dependencies, and also when our all sees this dependency, it will go, this file doesn't exist. Let's find a rule in here to make it exist. And this rule, this funcs rule exists, so we jump down here and we go main.o. That file doesn't exist, so let's jump down here and compile it. And that goes on and on for all of these. Well, these dependencies already exist because we wrote them by hand, so this will just run. Okay, so now if we type make, we see that it actually does gcc tac-o, well, all of these, and I might have messed something up here. Remove a.out, func01.o, func02.o, main.o, and funcs. Whoops, main.o. Well, okay. So now we've cleaned out, and we'll learn how to clean very soon, but we've cleaned out all of our directory, and now we can type make, and we see that it runs gcc main.c, then the same for func1 and func2, and then finally it links them all together and it creates this funcs file or binary. And we have all of these, and we have our funcs, so we can run funcs. Great. So this is what we expected to see, and it may have taken a minute, but now we have all of this, and we can, instead of compiling everything every single time we make a change, we can just do make and then /funcs. Okay, but this is a little bit big. We have a rule for every single C file, and anytime we want to add a new C file, we have to make an entirely new rule, which means copy and pasting these lines and changing everything, and changing things up here and in here as well. So there are a lot of problems with just typing everything out like this. So instead, we can do some shortcuts. So I will keep, well, let me just keep this main.o down here so that we can reference back to it, and we can look at some shortcuts. So we have three shortcuts and a few new ideas to talk about here. And I guess I'll go with the new ideas first. So we can create, in makefiles, we can create variables. So let me create one called prog, or our program, and I'll just say funcs. So that is a list of size 1, and our program is called funcs. And so down here, when we reference funcs, well, we see these two are the same, we can do $prog in parentheses, and this will, whenever the makefile is running and it sees this, it will call back here and say, okay, put in funcs here. And right now it seems like we're actually typing more to have this program, but it's very easy now to just change our program because we can change it in one place, and then everywhere else it will change. And we can also have multiple programs here if we want. Okay, and then let's change it down here as well. Prog. Great. So we've gotten rid of that, but then we also have references to all of our .o's in a lot of places. So we can do, well, objects, or you can call these variables anything you want. I'll just call them objects, OBJs. And now I'll list out our objects. So main.o, func.o, func01.o, and func02.o. And you'll see in some of Kaufman's make files that he puts a / here and a new line and maybe a tab, and then he types some more down here. That just means that in this variable call, once it gets here, it knows to keep looking to the new line. But I'll just have it all on one line for now since it's small. And so now we have this list of objects, and we can reference them much easier. So here we have the same list, and we can just delete this entire line and go, or the entire rest of this line and go, okay, we depend on our objects to exist. And down here, we can do the same thing. We can delete the rest of the line and go, we depend on our, So we can write, link together all of our objects, or we can use the next shortcut. And that shortcut, instead of writing it here, is if we ever change dependencies up here or add in some new ones that aren't just our objects, we can just do $hat, $hat, or caret, or up arrow, whichever you like to call it. And that will say all of our dependencies, so everything in this list, if we had funds.h here, would go here. So I'll remove that funds.h for now. Great, so now we have these much smaller lines of code, and we don't have to list out all of our objects every single time. Okay, so let's write the main.o rule. Well, actually, let's write all of the rest of the rules all at once with this next shortcut. We can do a %.o in order to say any string that ends in .o is going to be our rule. And so how the flow of execution works is when we get to this funcs rule and it looks through the objects, it's going to call them one by one. So it's going to go main.o. I need a main.o. And so it's going to jump down here and see, well, I can have something.o. I'll just put main in there in place of that %sign. Okay, so now we depend on %.c. So this %sign is now referencing back to whatever this was. So if we have main.o, it'll be main.c. If we have func1.o, it'll be func1.c. So we can depend on, so we can now depend on that same file but .c instead. And let's say, well, down here we depend on funds.h, so we can just write funds.h. And then we just write gcc tac-c. And we don't want to compile this funds.h because that would create a precompiled header, and that's not our goal. If you don't know what that is, don't worry. We don't really cover them in this class, but you're free to look them up on your own. but that would create a precompiled header. We just want this leftmost dependency. And so we'll go $left arrow. And this says, look at the very first dependency. What is that? Put it in here. Okay. So now I can delete all of those lines because this will run for every single dependency in this objects list. So it'll go main.o goes here. func1.o goes here. func2.o goes here. Great. And then one last thing that I forgot to mention, but here we actually have, we are writing funcs even though we should be writing prog. So I will write prog there. And then here, we're kind of redundant in writing prog. We can use yet another shortcut and just say at symbol. And so this little at symbol says, what is the name of this rule? Just put that here in this $at symbol. Okay. And now we can do make. Well, we have all of this stuff already made, so there's nothing really to do. So if we remove func01.o, func02.o, main.o, and our funcs binary, well, now we've cleaned everything out, and we can type make again, and yeah, it does the same thing. It runs through all of these, and then it links them together. Okay, and now I'll talk about one final thing, which is clean. So here I've said rm and then all of this stuff in here, and every single time I want to clean out my directory because it's a little bit unwieldy to read through all of this stuff with our .os. And also sometimes we want to just get rid of all of the executables and refresh from a blank slate. Well, I would have to type in all of this stuff for every single file and then also the executable. So instead I can do clean. And this functionality is pretty common. We just type clean in a lot of make files. And we don't really need any dependencies. We can just do rm, yeah, like recursive force or force. And we'll just go all of our objects and we'll do our program. So this removes all of our object files here and our program itself. And now if we make, oh, we have everything made, and then make space clean, we'll remove everything there. Perfect. And so now we see, yeah, we have this nice cleaned out directory. So one last thing, we have only single commands here, but we can do, and also I've defined all of these very common rule names, but we can write our own rules, and we can write multiple commands in here. So if I wanted to echo removing all executables or something like that, then I can do that. Yeah, and let's see, let's do make clean. It says echo removing all executables, and then removes all executables. So great, now it's printing out, but it's also printing out the command that it does every single time, which in some cases is handy because here we can see, oh yeah, it removed through the rm command. But here it seems a little bit redundant. So let's go back into our make file, And we can just put an @ symbol to say, don't print. Don't print what command we're doing. Just execute the command. And so now if we make, and then make clean, we see just removing all executables. Perfect. All right, the very last thing is back in our makefile, we can make whatever rule we want. So these are commonly defined rules like all and clean, but we can also do hello CJ, because that's my name. And we're gonna say, I don't know, we're gonna run ls, and then we are gonna run echo, this is my directory, or maybe that was my directory. Hello, my name is CJ, or something like that. I don't know. So we can make our own rule, and if I type make hello CJ, great. It does this ls, and it goes, that was my directory. Hello, my name is CJ. Great. So it doesn't run through, even though we use this make command, it doesn't run through all of this compiling. It'll just do this specific rule. And also, if we had a bunch of make files and we wanted to switch between, we just do -f makefile, and it runs that specific file. Okay, so that's about all I have for you all today. That's makefiles, or at least the simple part of them. You will likely be implementing them as your project 4, so they're pretty important to learn right now, and they're also pretty useful. That's why we teach them, because they're very useful if you're coding in C. Cool. So that's pretty much it for the first part of this lab. You should be able to go and do it all by yourself now. If this video isn't enough information, there are some examples in the makefile demo directories in the lab, so make sure to go check those out and see what's up there. And other than that, good luck on the lab. Leave a like and subscribe, and I'll see you all next time.